Welcome back to our series of lectures on Math 9. We are now in Chapter 7, and Chapter 7 covers variations. Lesson 7.1 will deal with the types of variation. Our objective for this lesson would be to differentiate each type of variation and also to give examples of each type of variation. Okay, so let's have the first definition here. What is a variation? Variation or proportion is a functional dependence among variables. This dependence tells how much one variable differs from another. We have variations or proportions are very common in the social sciences. Okay, when you do research in social sciences, you will have these relationships that you want to discover. Okay, so I have here written these types of variation for our own convenience. The first one is direct variation, followed by direct variation as nth power, inverse variation, joint variation, and combined variation. For all these variations, except the combined variation, the following statements are equivalent. Y varies directly as x is the same as saying y is directly proportional to x, is the same as saying y equals kx for some constant k. Now, again, if I say y varies directly as the nth power of x, it is the same as saying y is directly proportional to the nth power of x, or y equals kx to the n for some constant k. And you will see the pattern. Y varies inversely as x is the same as y is inversely proportional to x here, y is inversely proportional to x, or y equals k over x for some constant k. And for the joint variation, z varies jointly as x and y is the same as saying z is jointly proportional to x and y, or z equals kxy for some constant k. Okay, let's take the first type of variation. This direct variation. It would be easy to detect whether a relationship is direct variation, because direct variation for x and y means that y and x will change in the same direction. Meaning, if one goes up, the other one also goes up. Or, if one goes down, the other one also goes down. Let's take an example. For example, we have this one. Okay, so we have this statement. If y varies directly as x, and that y equals 15 when x equals 6, what is y when x equals 10? Okay, so let's have this pattern here. If we say y varies directly as x, we have this y varies directly as x, and we can write this as an equality by introducing the constant of proportionality. And from there, instead of doing the substitution here, we are going to get an equation expressing our k. K here would be what? Y over x. So if it is a direct variation, we have a ratio. So this is our pattern for our equation. The first situation is labeled as y1, x1, and the second situation is y2, x2. From the given problem, the first situation has y equals 15 and x equals 6. The second situation, y is unknown and x equals 10. So I'll just say here y. Instead of saying y sub 2, I will just say y over 10. Okay. Solving for y here will give me, I can cancel 15 and 6. 15 divided by 3 is 5. 6 divided by 3 is 2. So my k here is actually 5 over 2. 5 over 2. And then I can cancel 10 and 2 here. I get a 5. This gives me y equals 25. Note how I canceled. I can cancel vertically and horizontally, but not crosswise. Again, cancel numerator, denominator, or denominator, denominator, numerator, numerator. Therefore, y equals 25. Should you want to get this equation here, this equation will now be y equals 5 over 2. This is 5 over 2 here, times x. So this is the general equation describing the relationship between the two variables x and y. Let's see, for example, getting back to that equation, when x is 6, this will be 6 divided by 2 is 3. 3 times 5 is 15. So, y equals 15. Okay? And when x equals 10, this will be 10 over 2 is 5. 5 times 5 is 25. Therefore, this is our general equation. Although we just were asked what's the value of y, I wanted to show you that this is the general equation that describes this proportion. Okay? Let's have number 2. Okay. Y varies directly as the cube of x. The only difference between the first variation and this second one is there is an exponent in x here, nth power. Okay? So, y varies as the cube of x means y varies as the cube of x. Now, if we will make this variation, this proportionality symbol be turned into equality, we are going to introduce the constant of proportionality k, and this one now will be y equals x cubed. Again, if we solve for an expression on for k, if we solve for k, I will have y over x cubed. Now, this is again a ratio here, y over x cubed, indicating that we have a direct variation as well. And the first situation will be described as y1 x1 cubed equals y2 x2 cubed. Okay. From the given, note that this one is by k. From the given, when y is 16, that's the first one, x is 2. So we get here a 2 cubed. And we are looking for y. So instead of saying y2, I'll just have a y. And then x is 1/2 cubed. Okay. Simplifying this, 16 over 2 cubed is 8. And then I will get here y equal over 1 over 8. Okay. You can have this cancelled, and I have here 16 over 8 is 2. And solving for y, I will get y equals 2 times 1 over 8, or this gives me 1 over 4. Okay, I was able to get my value for k. I can now write my general variation equation there as y equals 2x cubed. Okay, this is the equation that relates x and y. Let's try to find out if we have this right equation. When x is 2 here, 2 cubed will give me 8 times 2 is 16. So we have it y equals 16. So that's correct. What about when x is 1/2? If this is x is 1/2, this will give me 2 times 1/2 cubed, or 2 times 1 over 8. Or that gives me a 1/4. Which is correct? We had y equals 1/4. Before we leave the first two types of variation, for direct variation, we were saying that if one variable increases, the other one also will increase. Or if one decreases, the other one will also decrease. Let's take this third type of variation. Y varies inversely as x. y is inversely proportional to x, y equals k over x for some constant k. What does inverse variation mean? I will have here writing the variation relationship. I have here y varies inversely as x, so 1 over x there. Then I make this equality. I will introduce the constant of proportionality so that I will have this one, which gives me y equals k over x. Or, solving for k, I will get k equals yx. So, for inverse variation, instead of having a ratio, we have a product of the two variables. So here, if one increases, the other one decreases. Inverse variation here of x and y means that y and x change in opposite directions. So, if one goes up, the other one goes down. Or if one goes down, the other one goes up. Okay, let's have an example of that. Here it says here y varies inversely as x. So we have this one, and y equals 1/5 when x equals 25. So our equation now here will be k equals y1 x1 equals y2 x2. And the first situation is y is 1/5 and my x is 25. And the second situation is y is unknown, so instead of me writing y sub 2, I'll just write y. And then I have a 10. And I cancel this off. I will get a 5 equals y, and this is over 10. This gives me 1/2. So the constant of proportionality is 1/2. Oh, my general equation therefore is no. Wrong. Okay. Here, solving for y, I will cancel this. I will get a 5 equals 10y. This gives me y equals 1/2. Now, my value of k here is y1 times x1, or that's a 5. So therefore, my equation here is y equals 5 times 1 over x, or y equals 5 over x. This is the general variation equation. Let's check our work. When x is 25, can we get y equals 1 over 5? Okay, when x is 25 here, we have 5 over 25, and that's 1/5. That's correct. What about when x equals 10? When x equals 10 here, we will get y is 5 over 10, or 1/2. Okay, so here, if you increase the value of x, you will expect a decrease in the value of y. Or if you decrease the value of x here, there will be an increase in the value of y. That's when we say the two variables are varying inversely. Okay? The fourth type we will discuss is joint variation. When we have a joint variation, there will be three variables varying. Okay? One variable varying against two variables. Okay? And the same direction. If both are okay. Forget that. Let's have an example of that. Okay, example. P varies jointly with R and S. If P equals 16, when R equals 5 and S equals 8, find P when R equals 2 and S equals 10. Okay. Let's take a look at that. P varies jointly with R and S. Our equation will be that Z equals KXY, or P varies jointly as X and Y. This will give me P equals KXY. Now, I can solve for k here. K will give me p over xy. And I will get here, first situation, p1 x1 y1 equals p2 x2 y2. Let's get back to the problem. If p equals 16, that is my first situation. Okay, I'm sorry. That should be, I will erase. Okay. P varying jointly with R and S means P equals K, R, and S. And this gives me K equals P over R, S. Now, this one defines the relationship of the three variables. So, first situation, P1, R1, S1. Second situation, P2, R2, S2. So, we just have to substitute. Okay, the first situation is P is 16 when R is 5 and S is 8. Then, instead of me having P2, we find P. So, I just say P here when R is 2 and S is 10. Okay, in this situation, what did we say? We can make cancellation vertically or horizontally. I can have this cancelled and I will get a 2 here. But I can cancel also 5 and 10 here, so I'll get a 2 there. So I'll have 2 times 2 is 4 times 2 is 8. So my value for P is actually 8. Okay, what is the value of this? 16 and 8 is 2, and then I will have a 5. So this is actually 2 over 5. Okay? So now, my general equation therefore will be P equals 2 over 5 R times S. Let's see if this one fits. Although we are not asked for this equation, we try to find out if P equals 8 indeed is correct when R equals 2 and S equals 10. Okay, so if R is 2, we have here 2, 5, R is 2, and S equals 10. What P can I have? 5 and 10 cancels off, so 2 times 2, 4 times 2 is 8. And we got an 8, so it is correct. Let's have the first case. Let's see what happens if R is 5 and S is 8. So the second case will be, will we get 16? Okay, with P equals 2/5, what is my R? It is 5 and my S is 8. I cancel this and I get 16. So we have the correct variation equation. Okay? Let's have this last one. Okay, let's have combined variation. When a quantity is directly proportional to some variables and inversely proportional to other variables, our variation is called combined variation. So, it's not totally all inverse, it's not totally directly proportional, but it's a combination of inverse and directly proportional. Let's have this example. Q varies as V and inversely as W. If Q equals 10 when V equals 8 and W equals 5, what is Q when V equals 12 and W equals 15? Okay, it's more like the joint variation, except here we have an inverse and we have a direct variation combined into one. Okay, so let's have this. Q varies as V means I have a V on top, and inversely as W means I have a W below. Okay, so this is my variation equation. If I solve for K here, I will get here Q times W all over V. Then, this is my basis for solving the problem. Q1 W1 over V1 is the first situation. And what is Q? So, QW2 over V2 will be the second equation. Now, substituting the values. Q1 is 10. And what do I get for W1? I have a 5. And I have an 8 here for V. What is Q? So, that's Q is unknown. W is 15. And V is 12. Okay. Suppose I will not cancel. I can have here cross multiplication. I will get 8 times 15 times Q equals 10 times 5 times 12. Or Q will give me 10 times 5 times 12 over 8 times 15. Tama. Okay. So, I can cancel 10 and 15 by 5. I will get here a 2. 15 by 5, I get a 3. I can cancel 12 and 3. So, I will get here a 4. And I can cancel 4 and 8. So, I will get a 2. So, what do I get here? 2 times 5 is 10 over 2. Okay, that's a 5. Q is 5. Now, if I have to solve for K here, what will be K here? 10 by 2 is 5. 8 by 2 is 4. My K is equal to 25 over 4. So, my equation therefore is Q equals 25 over 4 V over W. Although we were not asked to get the equation, this is the equation. We were only asked to solve for Q. Let's check whether those Q's are correct. Okay? Now, the first situation, if V is 8, let's say, 25 over 4 times V is 8 and W is 5, will we get a Q that is 10? Let's find out. 25 and 5 is 5. 8 and 4 is 2. Indeed, we have a 10 for Q. Let's have the last one. If we have here 25 over 4 and then we have a V which is 12 and then a W which is 15, let's find out if the Q that we get is 5. Okay? So 12 and 4 is 3. 25 and 15. 25 divided 5 is 5. 15 divided 5 is 3. And 3 and 3 cancel out and then we get Q equals 5. So indeed, this is the general variation equation. See you on the next video.